Chapter 4, Section 5, Deleting Missing Data by Python. In the previous section, we learned the overview of how to handle missing values. In this section, I will explain how to delete rows or columns with missing data by Python. There are cases where we want to delete only rows or columns that meet certain conditions, rather than deleting all rows or columns that contain missing values. In such cases, how can we delete only the rows or columns that meet certain conditions? Deleting rows or columns containing missing data is a last resort when other methods are unavailable. The simplest method is to delete all rows or columns that contain missing data, but this can result in a significant loss of information in the dataset. It is recommended that we return to the basic principle of keeping as much data as possible and delete rows or columns that do not significantly reduce the amount of information. The following situations are cases where deleting rows or columns will not significantly reduce the amount of information. Rows that contain many missing values. Columns that contain many missing values. Rows or columns that contain missing data account for only a small proportion of the total data. Using Python, we can efficiently delete data based on the above criteria. In the following code snippets, df is the name of a data frame. First, here is a code to delete all rows containing missing data. The dropNA method is used to delete rows containing missing data. How equals any means delete rows containing even one missing value. By specifying in place equals true, it overwrites the original data frame, df, instead of creating a new data frame. The code for deleting all columns containing missing data is almost the same as the code for deleting rows. The only difference is that we have to set axis to 1. This means operate in column direction. Setting axis to 1 tells the computer to delete columns, not rows. As the previous case, we set how equals any to specify the condition, delete columns with at least one missing value, and set in place to true to overwrite the original data frame. Next, let's delete rows with a lot of missing data. There's no single best criterion for a lot, so the analyst needs to decide for themselves. Here, let's delete rows where the missing data accounts for 30% or more of the data. You can do it using this code. It may look complicated at first, but if you break it down, you can understand the structure and implement it yourself. First, create a variable named threshold and set a value to determine the threshold. In this case, we will set it to 0.3, that is 30%. With this setting, we set a rule that a row will be deleted if more than 30% of the data is missing. By changing the value of the threshold, you can adjust how much missing data is allowed. The following line is the code to delete the data. Here, we use drop instead of dropNA. Inside the brackets of drop, we specify the data to be deleted and the method of deletion. First, the data to be deleted. The data frame df is followed by square brackets, and then followed by an index. This means that we will select only the data that matches the condition defined within the square brackets, and then obtain the index for that selected data. In other words, the code will extract the data that matches the specified conditions and then delete them using drop. In this case, the condition for deletion is rows with a missing value ratio of 30% or more. So we write the code for this condition in the square brackets. Now let's focus on the condition specified the square brackets. First, let's focus on the part is null mean axis equals 1. Is null checks whether each element in the data frame is missing. It returns true where there are missing values, and false where there are no missing values. The mean axis equals 1 calculates the percentage of missing values for each row based on the results. The return value of is null, true, is treated as the number 1 and false as 0. So, using mean parenthesis allows you to find the percentage of missing data in that row. Next, let's focus on the part larger than threshold. It checks whether the missing data rate for each row exceeds the threshold value. If the missing data rate for each row exceeds the threshold value of 30%, it is classified as true, and the row is selected for deletion. If the missing data rate is 30% or less, it is classified as false, and the row is not deleted. Let's go on to the next part. Index is used to obtain the index of the rows to be deleted, that is, the row number of rows to be deleted. The result of df is null, mean axis equals 1 is larger than threshold, is a series of Boolean values that indicate which rows should be classified as true, meaning that to be deleted. We use the method index to extract the index number of the rows that are classified as true. By using the index method, we can accurately determine which rows should be deleted, and then delete the rows based on their row numbers. In this way, we obtain the rows index where the missing data percentage exceeds 30%. We delete the rows that match this condition using drop. Using in place equals true, we override the original data frame, df, without creating a new data frame. Let's look at the above code using an image. Consider this simple data frame. Let's name this data frame as df. We can see that some cells are missing data. Applying is null to this data frame will return true if the cell is a missing value, and it will return false otherwise. This Boolean value of true and false is quantified. True corresponds to 1, and false corresponds to 0. Following is null, apply mean. Set axis to 1 to compute the mean value for each row. The mean value is calculated by converting true and false to 1 and 0 respectively. Next, set the conditional expression that the calculated mean value is greater than 0.3, which is the threshold. We have now set a condition for deletion, that is, the percentage of missing data is 30% or more. Then, by adding square brackets to the data frame, df, select only rows that meet this condition. The second row and the fourth row are selected. The mean values of these rows are greater than 0.3. Next, identify the index of the selected rows by using the index method. By identifying the index, it is easier to know how many rows we need to delete. Then, use the drop method to delete rows of the identified indexes. Inside the drop, set in place to true so that we overwrite data frame to reflect the deletion of the row. We have now deleted the rows with a missing data percentage of 30% or more. Next, let's delete columns with many missing data. There's no single best criterion for many, so we need to decide for ourselves. Here, let's delete the columns where the missing data accounts for 30% or more of the data. You can do it using this code. It is almost the same as the code for deleting rows, but there are some important differences. So, let's take a look at them carefully. First, as before, create a variable called threshold and assign threshold to determine how much of the data is missing. In this case, let's set it to 0.3 or 30%. By this setting, we can set a rule that if more than 30% of the data in a column is missing, the column will be deleted. By changing the threshold value, we can adjust how much missing data is allowed. If we use the same threshold value for rows and columns, we do not need to set it here because we already set it when deleting rows. If we use different threshold for rows and columns, we need to set them separately. In that case, it is better to use different variable names such as row threshold and column threshold so that we can avoid confusion. The code to delete the data starts from the next line. Again, we use drop to delete the data that matches the specified conditions. Inside the brackets of drop, we specify the data to be deleted and a method of deletion. First, we specify the data to be deleted. We add square brackets after adding the columns to the data frame df. This means that only the data that matches the condition defined within the square brackets will be selected from the column in the data frame. In order to set the column as the data to be deleted, it is necessary to use df columns rather than df before the square brackets. Now, let's look at the conditions specified in the square brackets. First, let's focus on the part is null mean. As before, we use is null to check whether each element in the data frame is missing. This returns true where there are missing values, and false where there are no missing values. The main function calculates the percentage of missing values for each row based on the results. When calculating the average value for each row, we set axis equals 1 in the brackets, but when calculating the average value for each column, the brackets can be left blank. By leaving them blank, we can set the default setting of axis equals 0. By default, mean calculates the average for each column. This calculates the percentage of missing data for each column. If this exceeds the threshold, true is returned. And if it does not exceed the threshold, false is returned. Next, set axis to 1 within the drop, outside of the square brackets. This sets axis equals 1 for the drop method. Setting axis to 1 in the drop method will delete columns. The default setting is axis equals 0, which deletes rows. In the code for deleting rows we look at the above, we did not set the axis for a drop, so the default axis equals 0 was automatically set, and the rows were deleted. If you set axis to 1 in drop, the drop method will retrieve the column label and delete the corresponding columns. Therefore, when deleting columns, we do not need to add index after the square brackets. Then, as before, by setting in place equals true, we can overwrite the data frame. In the code above, when you set axis to 1 in main function, it computes the average of each row, and when you set axis equals 1 in drop method, it deletes the columns. As you can see, the axis specification plays a different role depending on the method, so it is confusing. A mean is a method that calculates the average value for each element of the data frame. In this case, the axis indicates in which direction the method performs the calculation. Mean axis equals 0 is default, calculates the average for each column. In other words, it calculates in the vertical direction and finds the average value for each column. Mean axis equals 1 calculates the average for each row. In other words, it calculates horizontally and finds the average value of each row. Drop is a method for deleting rows or columns. In drop method, the axis indicates which direction's elements, that is, rows or columns, are to be deleted. Drop axis equals 0 deletes rows. This means that the elements in the row direction are deleted. Drop axis equals 1 deletes columns. This means that the elements in the column direction are deleted. Next, if the number of rows that contain at least a single missing value only accounts for a very small proportion of the total, we can consider there's no problem with ignoring those rows and deleting them. So, let's write the code to do that. Here, let's delete those rows if the proportion of such rows accounts for less than 5%. First, let's set the threshold value. The variable name for the threshold value is missing underscore percentage underscore threshold, and let's assign the value 0.05. In the next part, specify the condition using an if statement, and if the condition is met, we apply drop NA method to delete rows that contain missing data. By default, drop NA also has axis equals 0, so it will delete the rows. Therefore, here we do not set the axis, but only set in place equals true to override the data frame. Now, let's take a look at the conditions set in the if statement. Let's focus on the part df is null, any axis equals 1. Is null returns true if data includes missing values, otherwise false. By adding any to is null, the operation becomes one that returns true for rows or columns that include at least one missing value. Furthermore, by setting axis equals 1 within any, it will return true if the row contains at least one missing value, and otherwise false. Then, the main function computes the average using 1 for true and 0 for false. Then, the average is compared with the missing underscore percentage underscore threshold. In this case, the threshold value is set to 5%. So, if the mean is less than 0.05, any rows that contain at least one missing value are deleted. In other words, the rows for which is null any axis equals 1 returns true are deleted. In this simple example, 65% of the rows contain at least one missing value, so these rows cannot be deleted. The above operation deletes rows with missing values if there are few rows with missing values. Next, let's consider a case where there are few rows with missing data for a particular variable, and we want to exclude those rows. If there are very few rows with missing data for a particular variable, deleting the rows with missing data for that variable is unlikely to significantly affect the overall result. As with the previous code, let's set the threshold to 0.05. If rows with missing data for a particular variable account for less than 5% of the total, we will delete those rows. First, set a variable that will be used as a criterion for deletion. The deletion of rows is limited to cases where the proportion of missing data for this variable is less than 5%. Create a variable called column name and assign the name of the variable that we will use as the criterion for deletion. In this case, the variable name is your column name as an example, but please enter the name of the actual variable you use as the criterion. Set the threshold in the same way as before. In the next part, specify the condition using an if statement. If the condition is met, we apply drop NA to delete the rows containing missing values. This structure is the same as before. The difference is that we set the argument subset in drop NA. In the subset, using square brackets, enclose the variable that we use as the criterion. In this way, only the rows with missing data for this variable will be deleted. When setting conditions using an if statement, specify the rows where the percentage of missing data in the target column is less than the threshold value. Since we specify a column, add square brackets after the data frame named df and specify the variable inside. Then, as before, you can calculate the percentage of rows where this variable is missing data by combining is null and mean. Thank you for watching. Please thumbs up and subscribe to my channel.